Hello and welcome to another free code session. My name is Jason Bach, and in this special episode, I'm going to be talking about a new library that I just created. It's only in 0.10 land, but it's something that I plan on adding more to, and it's been a fun thing to work on because it deals with source generators, and source generators are so much fun. But this is something I had an idea about. I was studying some Python near the end of the year and came across partially applied functions, which I've seen before. I think F# has them. Another language I looked at a while ago called Pony, I think, has them as well. And I thought, well, could you do this in C#? And I started looking, and there's a couple of examples that use func and action to do it, which is fine. But I thought, could I kind of take this one step farther and do this with source generators in such a way that the code is just generated for only the functions that you want to do partial application on. And furthermore, because as I did in rocks, I can project types as needed. So if you have ref arguments, out arguments, open generics, if you've got the ref structs, pointers, in all cases, I should be able to generate delegates when I need to so that I can do this partial application. Okay, so that's what I have right now. I'm going to show you what this does and then talk a little bit about where the future is going to go with this. So let's say I want to do a partial application on add. So I say var increment by 3 is equal to, now partially.apply doesn't exist. Partially.apply, but now if I pass in maths.add and I say 3, now everything suddenly comes into play. I'll dive into the code in just a minute so you can see what happens. And then if I do console.out, we need system here, right line, increment by 3, and we're going to pass in 4. Okay, now let's do the same thing for the multiply. We're going to do a tripler. We're going to do partially apply. Now you see this is showing up in IntelliSense because it's actually been generated, but what we need is a version of this for multiply, which so happens to be there. So we're going to actually, you'll see again what I mean by that in a moment. So now we're going to say console.out.write line, tripler 3. Okay. Now the last one we're going to do is var increment by 4 and 5. Okay, we're going to say this is equal to partially.apply maths.sum, and we're going to pass in 4 and 5. Okay, now we're going to say console.out.write line, and we're going to say increment by 4 and 5, except we're going to pass in 6 and 7. Okay, now if I run this, if all works and works well, we should see 3 values in the console window. And they are 4 incremented by 3, which is 7. 3 times 3 is 9. And then adding 4, 5, 6, and 7, which that feels like 22. So they all worked. Okay. So what's actually happening here? It's actually very little code. When I hit F12 on this, we now dive into the generated source code. And as you can see, this one was created for both maths.add and maths.multiply. And I did this on purpose. I do this on purpose because it's not where the method is defined on whatever class, if it's static or object, if it is an instance, it doesn't matter. It's the signature of the function itself. And in this case, we have a func that takes 2 parameters, int, and returns an int. The partial application will take an int and return an int. Okay, and the value we're passing in to apply is the first one, the a. So what I do is I just create a new func of the thing that needs to, the partial application function thingy that gets sent out, but we close over a by passing it into whatever the method was here, and it just all works. Okay, the same thing happens here with the sum. So we generate the right function, the right func signature for the first argument, the 2 values that we know we're going to close over, and then a func that lets you pass in 2 more values, and returns the result. Okay. So this just all works. Now, right now, this is limited to just things that can be specified by func and action, which for a lot of things will be more than sufficient. Okay. If you have a method that takes more than 16 arguments, then I feel sorry for you because that's a lot, but then this won't work because we can't specify an action or a func that has that many parameters. If you have refs, outs, ref structs, those types of things, this won't work either, but that's on the list. And I am planning on getting all that stuff supported. It's just for right now, this is what you can do. But it's been fun to get something like this to work. And it, like I said, it ends up being a very small amount of code. And one implementation I saw of this when I was doing my research, basically kind of does this for all possible cases, more or less, where in this, I'm just generating only what's needed and no more. So for right now, I just have 2 applies. Okay. And if I started doing more, like, let's just say I wanted to do var apply 3 to sum. Okay. So we're going to 3 values to sum. I can now say partially, at least now I get IntelliSense maths.sum. And I'm going to say 1, 2, 3. Okay. Now, if I come back over here to generate, you're going to notice there's now another function that's been generated because we're passing in 3 values here. And so I pick that up and I do the right thing. And then that would work. If I now say here, we're going to do this and pass in just 1 value, 4. Okay. And we hit enter. You'll now see that it does the right thing and gives 10. So give this a try. It's called partially. Let me get this right here. PartiallyApplied. It's in NuGet. If you go to github.com/jasonbox/partiallyapplied, that's where the repository is. And as you can tell, it's just version 0.10, but there will be more work coming in the future. So that's all for this special episode. I hope you enjoyed it. Leave your comments and questions below. See you in the next episode.